All right, so everybody should have out Note Guide 6.3. We're going to start it in just a minute. The last thing we're going to learn today is how to use standard molar volume to convert between moles and liters and moles. So Amadeo Avogadro is kind of credited with this, and that's why the number comes from 6.02 times 10 to the 23rd is named after him as Avogadro's number. And he said that equal volumes of all gases at the same temperature and pressure contain the same number of molecules. So what this is saying is the identity of the particle doesn't matter, just how many of them you have. Okay, if you have a certain number of gas particles, no matter what they are, you have a certain volume. But this is also dependent on temperature and pressure. And they found that if you have standard temperature and pressure, okay, which is 273 kelvins and 1 atmosphere pressure, we're going to write that down in just a minute. So if you have that temperature and that pressure, if you have 1 mole of any gas, whether it's a heavy gas or a light gas, if you have 1 mole of any gas, it's going to occupy a volume of 22.4 liters. Okay, so if you have any gas in a balloon, again, a flexible container, at 1 atmosphere and 273 kelvins, it's going to always occupy that same volume of 22.4 liters. Now notice the mass is going to be different because each of these gases have different masses. But if I have that same quantity, 1 mole, if I have that same quantity, 1 mole, okay, it's always going to have a volume of 22.4 liters. So what we can do is we can use that to convert between moles and liters and moles. If we're going from moles to liters, moles goes on bottom. If we're going from liters to moles, liters goes on bottom. But we're going to use that same process that we've been using to just add one more conversion to it, to fully complete our conversion chart. So let's have our note guide out and let's fill this in quick before we do some examples. So starting on our notes, recall that STP stands for standard temperature and pressure and represents conditions of 273 kelvins and 1 atmosphere pressure. So at STP and only at STP, it has been found that 1 mole of any gas will occupy a volume of 22.4 liters. So what we can do is we can write this as a conversion factor, where 1 mole equals 22.4 liters, or 22.4 liters equals 1 mole. So if I'm going from liters to moles, again, this is going to go right here, liters on bottom, moles on top. Or if I'm going from moles to liters, moles is going to go on bottom, liters on top. So I can use these conversion factors to get from liters to moles or moles to liters. All right. So take a moment and finish up the top of your note guide, and then we're going to do some quick examples before we again get some work time. So let's start with example number 1. At STP, how many liters will 3.85 moles of ammonia gas occupy? So again, I like to underline where I'm starting. 3.85 moles, I'm going to liters. So it looks like I'm starting here, I'm starting at moles, and I'm going to liters. I'm starting at moles, and I'm going to liters. If I'm starting at moles and going to liters, this is going to be my conversion diagram. So I'm going to start with that 3.85 moles. It looks like 1 mole is going to go on bottom. 22.4 liters goes on top. Do I multiply or divide? Hopefully we can all answer that question with multiply. And I should get an answer of 86.24 liters. And that is our first conversion from moles to liters. Let's look at example number 2. Let's look at example number 2 next. All right, on example number 2, it says how many moles if I start with 73.9 liters. So it looks like I'm going from liters to moles. So this is obviously going to go up front, and I'm starting at liters. I'm going to moles. So I'm going to use this conversion factor, and I know you can't see it that well, but hopefully you can on your sheet. If I'm going from liters to moles, it looks like 22.4 liters is going to go on bottom. 1 mole goes on top. So in this case, I'm going to divide. 73.9 divided by 22.4, I should end up with 3.30 moles. Next question, I'm taking that to molecules. So I'm going to go up here to representative particles. So if I want to go to representative particles, I should ask myself, is it going to be easiest to start at liters or start at moles? And hopefully your answer is start at moles. If I'm at moles, or if I can get to moles, it's one step to anything, including particles. Okay, so if I'm going from moles to particles, I'm going to use this conversion factor here. And I'm going to start with my 3.30 moles, which I got in as my answer for my last question. And I'm going to particles, so 1 mole is going to go on bottom. 6.02 times 10 to the 23rd is going to go on top. Now, because this is a covalent compound, remember my unit for particles is going to be molecules. So I take 3.30 times 6.02 times 10 to the 23rd, and I get 1.99 times 10 to the 24th molecules. All right. All right, so we have one more question at the bottom, and then we'll do an example from the back. The last question in example 2 is a continuation of this problem, but now we're going to mass. So far we've started at liters, we've gone to moles, and then we've gone to particles. Now it says what is the mass. So again, where's the easiest place to start? Is it going to be easiest to start at liters, particles, or moles? Hopefully your answer, moles, because moles is one step to anything. So I'm going to take my moles from my answer from part 1 of example 2, and I'm going to turn that moles to grams. So I'm going to start with my answer, which was 3.3 moles, and I'm going to go to grams with the molar mass again going on top. The molar mass of ammonia being 17.04. I take 3.3 times 17.04, and I get 56.2 grams. Now, could you do this in a two-step problem? Yeah. You could start with liters and go to moles and moles to grams and do it in 2 steps, and you're going to end up with the same answer. But hopefully we're starting to kind of understand this chart better and utilize it the best that we can. And understanding that if we have moles or can get to moles, that's my bridge to everything else. In this case, I had moles, so that's going to be the easiest place to start, so that I only have a one-step problem to get to anything else like particles or grams. All right, so there's my examples. Let's go ahead and flip 6.2 over, and let's do our first example of your homework problems. So in your homework, the first question says, what volume will 1.27 moles of helium occupy? So it looks like I'm going from moles to volume. Now, volume is in liters, so if it helps, you might want to write volume down here, okay? So when it asks for volume, it's asking to go to liters. When it asks for mass, you should go to grams, okay? So if it helps, write this down, okay? Volume is down here at the bottom. That goes with liters, and mass is up here going with grams. The grams is a unit for mass. Liters is a unit for volume. So I'm starting at 1.27 moles, and I'm going to volume, so one-step problem. My 1.27 moles goes out front. 1 mole goes on bottom. 22.4 liters goes on top. I go ahead and multiply, and I should get my answer of 28.4 liters. All right, and the rest of this worksheets, number 2 through 7, is just, again, utilizing this conversion sheet just like you did on worksheet 6.2. So that hopefully allowed us or helped us reach our goal today of just understanding how to totally utilize this conversion chart. Okay, this handout 6.1. Your job is to finish and make sure you have done for next class worksheet 6.1, worksheet 6.2, and worksheet 6.3. Make sure you have all 3 of those done, and then we'll do an activity on Friday, and then we'll have a quiz on Tuesday. So we do have a quiz coming up. Remember, if you still didn't take your unit test, I do want to go over that on Friday. If you still didn't take your last unit test, I do want to go over that on Friday. So please, please, please take the test. Okay, come in before school, after school, during HIP, or whenever. Get that test taken. Okay, so again, everybody's working on 6.1, 6.2, 6.3. If you want to work together, that's fine. Please help each other. If someone around you doesn't understand, I'm sorry, I'm not here today. So make sure that you're helping those around you, okay? Have this done for next class, and then we'll start with an activity next class and a quiz the class after. So good luck. If you have any questions, I can see you during HIP, okay?